So what happens if we have an equilibrium and then we disturb it? Maybe we add some reactant or add some product.
The equilibrium changes?
The equilibrium is going to change. It's going to adjust. So Le Chatelier studied equilibria, and so we call this Le Chatelier's principle, that when a chemical system at equilibrium is disturbed, the system shifts in a way to minimize the disturbance. So if we take an equilibrium between N2O4 and 2NO2, and initially we have all reactant, and that starts to form product, and as the product forms, it starts to form reactant and go in the reverse direction, and eventually we get to the point where these are equal and opposite in rate. The rate's equal. And so the concentration of NO2 is now constant, even though NO2 molecules are constantly being formed and destroyed. So we've got an equilibrium set up there, but now what happens if we add some NO2 to the system? That's going to cause the equilibrium to shift to the left, because we've got more NO2. That's going to cause the reverse reaction to increase. And so the reverse reaction is going to increase, forming more N2O4, which will cause the forward reaction to increase a little bit, and they'll jostle around until they come up to a new equilibrium. I just remembered another analogy I have for this. It goes back to the miniature golf thing. So that's me, and this is Andrew. And he's got curly hair. What? I just want to make some, that's his hair. It's pretty wild. So we're playing miniature golf, and we've got a whole bunch of, and this is typically how miniature golf is played with 4-year-olds. You don't actually play miniature golf. You hit balls around, right? That's not nearly big enough. Okay, let's do this. Come on. Oh, those are big golf balls. So, we've got a bunch of golf balls over here, and I'm hitting the golf balls to his side, and he's hitting the golf balls back to my side. So I'm better at hitting golf balls than he is, and so more golf balls are going to end up on his side than on my side. But we're both hitting golf balls back and forth, and eventually it'll come to this place where we're hitting them over at the same rate. Because if I'm really good at hitting them over, I'll hit them back as soon as he hits them over. And if I'm just a little better than him, there are going to be a few on my side, and there's going to be a whole bunch on his side. He's hitting them over as fast as he can. If we add more golf balls, that's going to affect the number of golf balls on each side. A new equilibrium is going to be established. So let's say, can I do this? I erased my leg. So let's say that this was how the equilibrium was. And I was essentially hitting the balls back as fast as he hit them over, and he just couldn't keep up. But now, if we put, say, 3 more balls over here, now I'm going to have to hit them back faster, and we're going to get back to an equilibrium, but now he's going to end up with more balls on his side than he did before. Does that make sense? The equilibrium will shift. It will reestablish, but it'll shift. And so the equilibrium takes a disturbance and changes in a way to minimize the disturbance. Let's make the best of this situation. We were nice and steady, and now you throw this in at us, so let's compensate and make things as the same as possible. It's kind of... So back to the population. So we had established this balance in population between Narnia and Middle-earth. And now we're messing with that equilibrium. Here's a whole bunch of hobbits that just came in from outer space. And so they get dropped in here. They're aliens, yeah. Alien hobbits. I bet you didn't know they were alien hobbits. Maybe they were moppets or something. Anyway. So the concentration of people over here increases suddenly. Well, that's going to cause more of them to move to the other side, back to Narnia, because there's more opportunity over here. There's more space. Question?
Yeah, that, sorry,
It's okay.
last equation. I'm just kind of confused, like when you actually wrote out the equation, like if it was x times y over z, and you were solving for x, like since x is on the numerator, you don't have to multiply by the reciprocal on both sides instead of, you know what I'm saying?
Yeah.
It doesn't, you don't do that, like the CO2 would be x.
The CO2 is in the numerator.
Yeah.
And so essentially what I'm doing here, let's get a visible color, is I'm moving this up here, and I'm moving this down here. And that leaves this on this side. It's, you need reciprocals when you have something in the denominator.
So you're multiplying by COF2 and dividing by
CF4. Mm-hmm. Yep.
Oh,
Good. So we throw a bunch of extra people into Middle-earth, and that causes the population to shift to Narnia. But then a new equilibrium is established. The people are moving out of Middle-earth to Narnia to minimize the effect of that change. Now, at the new equilibrium, there'll still be more people in Middle-earth than there were before the disruption. But we've shifted to minimize that. So it's not all those people stay in Middle-earth. Some of them end up staying, but some of them go over to Narnia. And so we can look at the effects of doing different things to an equilibrium. So here we have an equilibrium, and we've got the N2O4s and we've got the NO2s. And if we add more NO2 to this, okay, so we're adding product, that's going to cause more reaction between the products to form the reactants, and it's going to cause this to shift. So these guys are going to react together, and we're going to end up now with more reactant than we had before. The system will shift to the other direction. So if you add product, the system will shift to the reactants. If you add reactant, it will shift to the products.